In this video, we're really going to focus on building understanding around the factoring process, and then we're eventually going to get to how we actually factor. So to start, we're going to really be looking at rectangles on this, and if we're trying to find the perimeter of a rectangle, really what we're trying to do is we're trying to find the distance if we walked all the way around it. And so if we did this, this opposite side of a rectangle is 8, this opposite side is 4. So if we added all those up, the perimeter is going to be 24. So that's perimeter. If we're looking at the area, we're looking really at the area of this as if we had all these boxes. So if you remember way back when, you would actually count up all the boxes. But we know that if we can, in order to find the area of a rectangle, it's length times width. So the area of this rectangle is 32. That's going to be really the foundational thing that we're going to build on, is the area being the length times the width. That's so important as we look through this. And so there's a relationship between 4 and 8 and this area being 32 and its multiplication. If we look at this one, the area is still going to be the length times the width, except it's going to be 4, and then it's going to be times 8x. And so we would say that the area of this one is 32x. We would also say that 8x and 4 are both factors of 32x. Factors meaning that they're things that are multiplied together to get a certain value. So of 32x, the factors are 8x and 4. If we're looking for the area of this one, we're going to have the area is 8x times 4x, and that is 32x squared. So now we just have it a little bit more complicated. Both of them have x's, both of them have unknowns, but we still follow the same process in terms of multiplying these two together. So our first anchor concept is that the area of a rectangle is the length times the width. And so we're always going to return back to that. Use this example, 4 times 8 is 32. And then also the length and the width are factors of A. So factors are things that multiply together. So if we're given any value, we can actually find factors of that value. That will come in handy as we progress through it. So now, if we're given the area of this being 23 units squared, we would find the length and the width. So the area is the length times the width. If we say that the area is 23, the length, this one has to be 23, and this one has to be 1. So we would say the length and the width are 23 and 1. We could also, oddly enough, this is maybe the less common one, if this was 2, then this would be 11.5. So they still multiply together to get 23. So as long as they're multiplying to get the area, then those are factors, and that works. So either combination works, but again, they have to multiply to get 23. Right? Now, if we're given this as 15 units squared, this is obviously not going to be to scale, but we could say that, this side is 1, this side is 15, or we could say this side is 3, this side is 5. There's actually an unlimited number of possibilities with this. These are just the two most common. So we would say that 5 and 3 are both factors of this 15, and 1 and 15 are also factors. And so we could find those side lengths. Now, if it's 15x, you might be thinking in your head the different possibilities. This might be 5x. If it's 5x, then this is 3, because those multiply together to get our 15x. You might have x, and you might have 15. There's other combinations. I think you could use 3x and 5 as well. But as long as they multiply together to get our 15x, our area, then you're in good shape. So going back to this anchor concept again, the length and the width have to be multiplied together to get the area. If we had this one, there's different possibilities here. I'm going to go with 5x and 4x. Those multiply together to get 20x squared. I could also go with like 5x squared, and then this would be 4. There's a lot of different possibilities on this one as well. Again, as long as they multiply together to get the area. Now, this one gets a little bit more challenging. 15x squared plus 10. So you notice within our area, there's two terms. So that means, again, whatever we multiply together has to get that, but we have to keep in mind those two terms. So if we found this, like maybe 5 is one side. If 5 is that side, then this side has to be 3x squared plus 2. So that when we multiply them together, we get 15x squared plus 10. So that's really what we're trying to do here. So this is what we would call the factored form, right? It's been factored. And if we did the same thing on this other one, we try something, could be 1 and then 15x squared plus 10. So what comes into play here, what we're going to be really looking at is the greatest common factor. So that means the largest value that we can factor out. So like here we factored out a 5. Here we just factored out a 1, and it wasn't super helpful. It works in this case, but 5 would be the greatest common factor. So it's the largest one, and that will come into play later. But for right now, both of these work. Now, if we're given this area, two things that multiply together to get x squared plus 10x. If one side is x, then the other one has to be x plus 10. There might be other possibilities here, but if we were writing this, we would say it's x and then x plus 10. And again, this is what we'd say the factored form, which really just means that it's things being multiplied together to get in this case, the area. We could have other possibilities. We could have like 1 and x squared plus 10x. That would also work. You might even get creative, see some people do this, and it's like, if this one's 2, or maybe even 2x, what does this one have to be? Well, it's like 2x times something is going to give this. So that something is going to be like 1/2 x, and then I think plus 5 will get me there. So we could even get that creative there, and that means that this side is 1/2 x plus 5. As long as they're multiplying together to get it, that's a fine factored form. So again, this concept will always come back. We're always going to come back to this concept. Now, we're given this one. This one's a little bit more complex, but if we look at our 3 terms, see that a 2 probably can be involved. So like if this one's 2, then it's 2 times something that's going to get us this area. And that something is going to have to be 2x squared minus 5x and plus 1. So that when I multiply it back out, I get what I started with. So again, it's this area model. This would be your factored form of your original area. Given this one, again, anything can work here. So I'm going to make this side x because I see that each of them have an x, and specifically an x to the first. And so then I'm like, x times something, we'll get back there, and that something is x squared plus 10x minus 2. So that means that the other side has to be. And a really good check here is to see, do your factors, when we multiply them back out, do they get the area? Again, going back to that concept. This one, you look in like each term, there's not each term has an x, so we can't mess with that. There's no numbers that are kind of common there. So we need something else. And so when you play around with this, you end up getting like x plus 3 and x plus 2 as these side links. So we had like two things that multiplied together to get this. And you can just try a bunch of different combinations, and it ends up being like this. And so when you look at this, there are certain strategies that can happen, but the big picture is that these two things, the side links, the length and the width, have to multiply together to get this area. And so whatever we choose as factors, again, this being the factored form, has to multiply together to get that area. Here's another one. When you try this one, you play around with it a little bit. We got three terms, x plus 3, I think, and then x plus 4. So we'd say x plus 3 and x plus 4. Those multiplied together get this. Now you might be wondering at this point, I get that these two things the two side lengths have to multiply together to get this. How do I go about doing that? How do I even start that? What is a process that can help me? And there's some trends that definitely happen within this, and I want to show you some of those as we move along here. So looking at this with the strategy, let's apply a strategy. So we know that things have to multiply together to get this. We know that the two things that multiply together, if we go back to this box organizer, we know that two things have to multiply together to get x squared. We also know that two things have to multiply together to get positive 10. So now we have to figure out what things go up top here and on the sides so that this will happen. And then we call this the middle term. So we have to try to get the middle term, and that's going to be right here. So two things that multiply together to get x squared, 99.9% of the time that's going to be x and x. Things that multiply to positive 10. Positive 10 would be like, I think of 10 and 2. I think of 10 and 1, 5 and 2 as my possibilities. And so I'm going to just try 5 and 2. When I do, I get positive 2x and I get positive 5x. I need these to add together to get negative 7x. And so positive 2x, positive 5x, those don't add to negative 7x, they add to 7x. And so what I have to consider here is that I can use positives and negatives on this. So I'm actually going to change this and make this like this. So these two numbers, negative 5 and negative 2, still get me my positive 10. But now we have negative 2x and we have negative 5x. So our factors here that we came up with were x minus 5 from the top and x minus 2 from the bottom. And so that's how we can strategize here to find that combination. I always start with two boxes. I start with this box and I start with this box, with being the squared term and the constant. And then I start playing around with numbers up here and here that multiply together to get this value, but also to get that middle term. Ultimately, though, the two things that we choose, x minus 2 and x minus 5, have to multiply together again to get that area. So going back to that model. If I have this strategy, so I start with my squared term, I have 2x squared, and then I put negative 3 down here. And so when I look at this now, I need two things that multiply together to get to get 2x squared. That's going to be 2x and x, keeping it simple here. And then we need two things that multiply to negative 3. So we have 3 and 1, and we just know that one of those has to be negative. So it's either negative 3 and 1, or it's going to be 3 and negative 1. So I'm just going to choose, let's put negative 3 up here, positive 1, and let's just see what happens. We know that they multiply to negative 3. Now we just have to see what happens here. So negative 3x, 2x. When I put those together, I need to get this negative 5x, but I in fact got negative 1x. So I know that those are not the right ones. So then I try different ones. So I'm going to try minus 1 up here and plus 3 here. So I got really close here. I got positive 5x. So if I'm really close, I'm just going to switch the signs, make one positive and then this negative, and see what happens there. And so that's kind of a strategy you can develop here, is positive x, negative 6x. Now when I add those together, I get negative 5x. So my two factors were 2x plus 1 and x minus 3. And I'd write my factored form as x minus 3 and 2x plus 1. That would be our factored form. Go ahead and hit pause. Try this one on your own. And then here is the completed diagram. When we put the combined like terms, negative 8x, we get that. Everything else checks out. So our factored form here is 3x minus 5 and x minus 1. That would be our factored form. Now, with the last one that we want to look at, the first thing we want to do is find a GCF first. So if we can look at these three terms and find a GCF, we want to factor that out front and use that. So I see 3 goes into 3, 21, and 36. So when I do that, this means if this side's 3, this other one is x squared plus 7x plus 12. And then what I want to do, so right now in my factoring process, I have this. I want to take this portion and factor it again. So I'm going to pretend like that's my area, and I'm just going to see if I can factor it again. And so now I'm going to end up with x plus 3 and x plus 4 as the factored form of this. So instead of this x squared plus 7x plus 12, I'm going to write x plus 4 and x plus 3, but my 3 has to stay as a part of it, because remember, this whole thing has to multiply out to get the area. So we're going to factor out a GCF first for this. So I put the concept here in general, but the first thing we want to do with any of these is look for a greatest common factor. And then, so 3 was our greatest common factor. And we're going to take our other side and see if it can factor further. So we're going to consider it as the area and find the factors of it. And then I'm going to write it out fully so that the GCF is included. And that's how you're going to factor using the area model.